Hi guys, welcome back. This is Mallikarjun here. Let's start with the today's session, Oracle RAC Architecture. As you might see in my previous video, so where I started this RAC internal as a future series of multiple series where I can cover each and every topic on RAC internal concept. So I in my previous session I explained what is this course is going to be. Basically, this RAC internal course is on the deep dive into Oracle RAC internal processes and how it works and what are the configuration and then how the communication happens. So I already explained these are the uh, planned topics I'm going to cover in this future series. So this is my first session on RAC internal. So that is purely I'm going to be Oracle RAC architecture. So let's get started on my first session on this RAC internals. So I'm going to open this RAC architecture presentation what I prepared. Okay, so in this presentation, so I'm basically going to talk about the RAC architecture, how it came, and then prior to this RAC architecture, how Oracle was managing this clustering. So this RAC architecture has came uh, came from Oracle version 10.2. Prior to this 10.2, Oracle used to call it as a OPP, Oracle Parallel Processing, Oracle Parallel Servers. So I'm not going to cover that history. So my point is, my intention is to cover only on this RAC architecture. Let's get started with the RAC architecture. So before I proceed with the rack architecture, I wanted to show how the application tier and middle tier and backend tier and three tier architecture or two tier architecture or just a backend database, how the architecture is going to be. So let's open my architecture PPT here. So this slide basically talks about three tier architecture, where three tier stands for three layer of connectivity, where front end and middle tier or middleware or the back end. So the front end is going to be your any end application or end user devices, either a mobile or a desktop or a web browser or internet, or it might be anything. So where the end applications or users are able to access it. So that's going to be your front end or presentation tier. And next comes to the middle tier or middleware, where our application or web servers will be hosted to handle those incoming requests. Either the request might be an API calls or through application or Java based or HTTP or HTML based, whatever the request it is. So your middle tier business logic is going to handle those requests and send it to database tier. The database tier is basically the backend tier, where your actual business data is residing. So based upon the user request, the request has to send to database via web server or application server, and then the required result will be fetched from the database and or the backend storage, and then via again same web server or application layer it will goes back to requester. So this is how basically three tier architecture works. And then I'll just deep dive into how this theta architecture related to my database or my application. I prepared one more slide. Okay, where this slides basically talks about what is uh, let me delete this. Okay, what is difference between the rack and the standalone database. So this left hand side basically talks about my standalone database, and then this right hand side talks about the rack database. If you compare with this three layer architecture, this is my front end, and this is going to be my middle tier, and this is going to be my back end. So front end is going to be same, like I just made it as same between the rack and between the standalone. Front end is going to be same, either URL or internet based or mobile application or desktop or whatever it is the end user going to access your application. So those all application will comes to middle tier. These are like apps servers or web servers, whatever it is. So it will come to this, and then from there the request will goes to your actual database. Actual database is your any kind of data storage. Like it might be Oracle, or it might be SQL Server, or it might be IBM DB, or whatever it is, whatever data storage it is. So and then if you compare this backend or database tier, I just mentioned standalone here and then rack here. What exactly mean by standalone? Standalone means whatever the request from the application or the end user, all request goes to a single instance. Single instance, again, it is a again, you if you can refer in Oracle terminology, instance is a memory plus background process. So again, please refer my previous video where I explained database architecture. So instance is basically memory plus background process where all end user connections are established, and then through that instance it will communicate to actual data or data file or actual business data. So in this case it's a standalone. See, if in case if this instance goes down, and none of the application or none of the users are able to access your data, it's a complete downtime. Whereas if you come to rack, I made it as, instead of single instance, I made it as a three instance. So you can have multiple instance, 4, 5, 6. You can dynamically scale your instances. So whatever the end user or whatever the application request will all goes to the available instance, and through available instance it will all point to the same database or same data, where this can be achieved by dynamically scaling up or scaling down. So if you want to add one more, you can dynamically add one more node, and if you want to remove one node, and you can remove one node from this rack setup, you can have only one and two. So it helps dynamic scaling out and scaling in without impacting your business. So this is what the difference between the rack and standalone. My purely this topic is basically on the rack setup. So don't worry about this application tier or front end tier. So I am basically concentrating about the this rack, this clustering, how it is possible at Oracle side. So this is I'm going to explain here. So these are the just terminology I just mentioned. You just refer it. People can call it as a front end or client, client or web or mobile layer or presentation layer, anything they will call it. And similarly for the middle tier, you can call it as a middle tier or middleware or app server or web server, whatever it is, all stands for same. And then the backend you can either call it as a backend layer or database tier or data management tier. So anything you can call it, but it basically talks about the three layer architecture. So I hope this is pretty clear. So let's get started with the rack architecture. So rack architecture, right? So as you compare the three tier architecture, so whatever the client request, either might be mobile or web based or desktop based, whatever the request client sends, that will go to via internet, and then via internet it will go to public IPs, and then from the public IP it will connect to any one of the instances. These nodes are nothing but instances, as I showed you here, right? So these are the instances. These are basically database servers where the instance will be launched. So client connection will directly connect to any one existing node, and then it can be I'll explain you what is the internal concept, on what basis, on which node the connection goes. There's a load balancing happens at the rack called a scan, where the scan listener is responsible for managing the load and sending the request to any one of the surviving node, and then from that instance it will directly connect to storage server. So basically this has three tier architecture. I can if you can go back to my three tier architecture, uh, this front end, and there's a back end, and there's the database. So if you divide only this rack concept itself as a three tier architecture, you can see your client connection is going to be your front end. It is not a three tier architecture, but I'm just correlating to that three tier architecture. Front end is going to be your client request, either SQL or SQL developer or Toad or PL SQL or whatever it is. So those requests will via public IP, it will connect to your instances, and instances act like your middle tier. Don't get confused and don't stand by on these words, but I'm just correlating it. And then once it connected to instance, and your request will go to actual database storage, and from the database storage your data will be retrieved back to instance, and from instance data will be retrieved back, presented back to end user requesters. So it's kind of same concept is happening here, uh, but it is not a three-tier architecture. It is a backend. It's all happening at the backend tier, or back at the backend side of your application. So this is how it works from the client via public IP or public internet, public LAN. It will connect to any one of the existing node, and then from that any one of the instance, it will communicate with your actual storage. So actual storage either might be your SAN, or raw disk, or NAS, or whatever it is. So all will be ASM storage. So, and then from there it will go back to DB node. So how these instances will communicate each other? There's a network called interconnect. Interconnect is a private network. It's a private to this cluster. Only these nodes are communicate to each other, and this is a separate network than this public network. So I think this is clear here. All the client connection will go via public network, and then it will connect to any one of the instance. Instance is basically memory plus background, and that is going to be run on any one of the DB nodes or DB servers. And then these DB servers will communicate with interconnects. That is a private network where they will use for communicating each other. And all these DB nodes or DB servers or instances will communicate with your storage server. Storage server is going to be either SAN or NAS or raw disk. All will be resides inside ASM. So I'll tell all this concept on terminology, what is ASM, what is scan, and what is interconnects. So I will, if we refer my all future series, you will get to know. But right now you can just assume this is how it works in the rack architecture. So going ahead, so I'll just go in deep what exactly these instances or DB servers contain, right? So I can just ignore this part right now. So this public network and then the client request, and I'll just go inside this DB node. What all these DB nodes are the instance contains. So these are the nodes. You can have n number of nodes, I said, right, as per your requirement. You can scale out or scale in. You can add one more server or two more server, or you can remove one or two servers. Everything is possible in the rack architecture, right? So each DB node has its own OS. You can have DB node OS flavor like OEL or Red Hat or anything, any OS you can have it on. On top of that, there's a software called grid infrastructure, and then grid infrastructure. On top of that, there is a Oracle Real Application Cluster database home, and then on top of that database home, your instance will be running. Instance 1, instance 2, instance 3, and instance 4. And if you have like n number of servers, instance, then n number of instance will run, and then each instance are capable of receiving the end user connections. So just to think, each DB node has OS. OS is it's a local to each DB node. This particular OS is responsible for this server, and this OS is responsible for this server, and this is independent. OS is independent, and it is local, locally resides on that particular server. It is not shared across the all the servers. So if you come to grid infrastructure is a software, again binaries, or installed on all the nodes. You can install the grid binaries on all the nodes, node 1, 2, 3, 4, but the grid infrastructure is shared across all the nodes. So once you install binaries on all the nodes, I'm talking only about the grid infrastructure. Grid infrastructure is kind of binaries or a software you have to install on all the nodes independently. Once you install independently on all the nodes, and then you have to configure grid disk or storage disk or whatever it is, disk groups you need to create. Those disk groups are shared across all the DB nodes. So that is why this grid infrastructure is marked as a shared among all the nodes. It is grid disk is not going to be independent, it is not going to be individually to the particular nodes. It is shared across all the DB nodes. And then coming to Oracle RAC, Oracle RAC is again Oracle RAC homes, Oracle homes, RAC Oracle homes. Again, those are installed on all the nodes independently, and then it is shared across all the servers. So once you install Oracle home on all the nodes, you need to share that. There's a binary concept inside Oracle RAC. There's a RAC on library. You need to make it on so that that particular binaries will communicate as a one single Oracle home, and then those all will serve their independent instances. So on top of this real application cluster, we are going to install instances on this node. On all the nodes, we are going to install we are going to create the instances. Those all instances will communicate to single storage. Okay, let's go deep dive inside what is grid infrastructure, right? So I'll just go back to go to next slide. So this grid infrastructure, right? Grid infrastructure contain Oracle clusterware and Oracle ASM. Oracle clusterware is the software where is responsible for managing all your instances. Suppose Oracle automatic storage management ASM is an instance. It's going to run on all the nodes. For example, node 1, 2, 3, 4, I have mentioned as a 4 nodes. Your 4 Oracle ASM instance is going to run, that is automatic storage management instances, which is responsible for serving all the incoming client connection or data movement between the nodes or between the storage server to the instances. This ASM instance is it is running on each individual node and managing that particular node. And to manage all instances together, there is a software called clusterware software, grid infrastructure software, which is responsible to manage all those ASM instances. I'll show you all this concept in live demo. So just assume that there's a storage and there's a particular OS runs on all the nodes, and there's a ASM software or ASM grid infrastructure library that is basically grid infrastructure contains ASM instance and clusterware. These ASM instance and clusterware together, we can call it as a grid infrastructure. And then on top of that grid infrastructure, there's a Oracle real application cluster, that is basically Oracle binaries. And then on top of that, your Oracle instance will run. So I'll go ahead with the next slide. Okay, so then I will deep dive into one particular node and what are inside that particular node. So in my previous slide, I talked on high level services, high level funda, how the grid infrastructure and rack and storage works. And then now I'll take only one particular server, and then I will go inside that what are the components you can see in that particular server. So I'm explaining only, I'm taken one server here. So this server basically talks about what are the services makes all together the grid infrastructure, right? So as I said, there's a OS and it is independent to that particular node, and there's a node membership. Node membership, as I told you earlier, there's a master node and then the slave node, and then the master node is responsible for managing the other cluster nodes. For example, if you see this diagram, I have 1, 2, 3, 3 nodes. Assume that this node is a master and there is a node membership, master node as marked here, and then other nodes are serving as a slave node. So if this node goes down, this node membership, that is a master node, is passed to any one of the surviving node. So and then this node, if it is passed to this node, and this second node is going to be master node. So this node membership is something you can say that there's a voting disk that is shared across all these three servers. For example, voting disk will be in your ASM storage, in the storage disk, and then all these servers are responsible, all these servers are able to access that voting disk, and then that voting disk will be contains all this node membership, node information, which is master node and which is slave node, and everything will be, all this information will be contained in this node membership. And then there's a HA framework. HA framework is high availability, right? So if this node goes down, what happens if existing connection, for example, one user session is connected to this node 3, and then if node 3 goes down, what happens to that user session? Will that be going to switch over to any one of the node, or that connection is goes off or terminated? That HF framework will tell what is going to happen. If this node goes down, anything happens at the backend, is there any mechanism to automatically start services back online, or that connection will goes to any one of the surviving node? That everything will be handled in HF framework. And then there's a ASM instance, as I told, right? This ASM instance is specific to this node, and there's a clusterware software libraries which is responsible to manage all the ASM nodes and communicate as a unique. And then on top of that, there's a RAC. If you go back to my previous slide, there's a real application cluster, RAC Oracle Home, and then on top of that Oracle Home, there's a DB instance. That instance is again specific to each DB node. So instance is nothing but memory plus background processes. So if you can see here, ASM instance, inside it, I can say that there is a ACFS file system. ACFS file system is something, you can say it is a ASM cluster file system. ASM cluster file system. ASM cluster file system means if it is a disk group will be created on top of the storage disks. For example, I have a storage disk 1, 2, 3, all together 3 disk. I am going to create a disk group called data. That data disk group is mounted in using ASM instance across all 3 nodes. So if you want to access that disk group, you have to connect to ASM. So is there any mechanism I can use that disk group locally on this node? Is there any mechanism I can use that disk group locally on this node? Is there any mechanism I can access that disk group locally on this node without connecting to ASM or without logging into ASM or any application? So this is possible using ACFS. So that disk group you can format it using ACFS and mount using ACFS file system. And then once you format and mount it using ACFS mount system, you can mount that disk group, data disk group, as your local mount point. As you can see, all Linux servers has a local mount points like U01 /root or /boot, whatever the local mount point. Like that, you can mount that disk group inside this all nodes, whatever node. For example, on node 3, if you mount it, it will be /ACFS, or you can give any name /ACFS, and you can do your OS operation like CD into that ACFS ls, and then put some files and copy files. You can do all your OS activities inside that ACFS. This is one of the ACFS advanced feature. You can make use of that. So if you come to storage device, right? ASM, these storage disks are represented or given to ASM as a raw disk, and then on top of that we will be creating the disk group. So what all present under these disks? So this disk directly, the instance will not communicate with the disks. So instance will communicate with ASM. ASM will use this disks as a disk group. For example, as I said, assume that I have a disk 1, 2, 3. All disk 1, 2, 3 together, I will create it as a data disk group. That disk group I am going to mount it on ASM. So in that sense, this DB instance will communicate with ASM, and ASM internally talk to disk groups called data, whatever I created, and through that data disk group, all our data will be returned to actual disks. So then what all available in this disk? I can say that in this disk means in the data disk group. So I can have my voting disks, I can have my OCR files, and I can have my data files, and I can have my redo log file, archive log file, and I can have my control files. I can have even my password file, ASM password file, and many more. I can have many more files under this ASM storage. I hope it is clear, but as I go forward, and then this terminology will be very useful, and you will be familiar with them. And just for time being, you just understand these terminologies and keep remembering this: what is DB instance, ASM instance, what is HA framework, what is node membership, and what is ASM storage, ASM, like all this terminology. ASM stands for automatic storage management. So you can make familiar with these terminologies. So going ahead with the next slide. Okay, so as I told, like each node having all these services, like OS independent and particular, responsible for that server alone, and then node membership, and the HA framework, and then ASM instance on top of that DB instance. This HA framework, HA framework is not that easy, so it has n number of processes. So these all processes I listed out here. I will show you. To understand this particular slide, so I made a there's a two MOS document I mentioned here, uh, 1053.147.1. This is actually talks about all the rack internals. So I request everyone to go to MOS document and refer this particular document where it covers all the process or rack internals. And then similarly, troubleshooting, how to troubleshoot this rack if in case any issues or any process failures. So I'll just show you what are this HA framework. I'll just open this particular document I already opened here. I'll just go through that particular section. So what all that HA factors that HA framework contains. So HA framework, these are the you can see these are the processes it will contain, that HA framework contains. There is a init process at the OS level, that particular node, and that starts OHSD, and then internally that OHSD process is responsible for starting this ORA agent. Okay, so there's a init process that is going to span, and then it will start OHSD, and then internally that OHSD process is going to start CSSD agent and Vora agent, and those CSSD agent, Vora agent, and Vora root agent. These are the three main processes, and then responsible of spanning rest other processes in the cluster. The other processes are like MD, NSD, MD, and ASM and GPNPD, CTSSD and CSSD monitor, CSSD, and then after that it will launch Vora agent particular to that grid user, and then Vora root user particularly to that grid user or whatever the Oracle user you will use, and then other process like other daemons like EONS, ONS, scan listener, VIP, and GNSD, and other rest of the instances. It is going to start. This all together will makes your HA. Okay, so these all processes together makes HA framework, and then this is just a daemons I demonstrated here. So if you correlate with particular processes, these are the processes. These are the processes if you can see here, right? So OHSD, Vora agent, Vora root agent, and CSSD agent, and then these are the daemons. It will start, and then again internally it will start to our grid root agent and Vora agent, and then that internally fires or starts all these grid services. So I will cover each and every processes or daemons in detail. So time being, you just note it down, and just think these are the HF framework, how it works and how the starting sequence. There's a sequence 1, 2, 3, 4, like stage wise, all the respective process will start. So I request everyone to go through this particular master document and then just to have a look on that. It will be easy to understand the future series. So okay, let's go back to my slide. So I'll just continue, assuming that HF framework is kind of set of processes or bunch of processes going to start in particular phase wise, like phase 1, phase 2, phase 3, phase 4. Each phase and certain processes are going to start, and then that is responsible for starting the some other processes. So HF framework is not so easy. It is a bunch of processes all together. We can HF framework will be formed in ASM cluster or in the rack architecture. So going ahead with the next slide. Okay, so if I can uh, in the ASM or in the rack cluster or rack architecture, if I can say some processes are local to that particular node and some processes are shared across all the cluster nodes, and some processes are cluster level. So that you can see my list here. I made it as some processes are local to that particular node, and some processes are cluster. So it means it is global wise, so it is responsible across all the nodes. So you can divide the resources like local resource and cluster resource. So this color in this, I can say it is local. If you can see this local processes, local resources, ASM is local to this no particular node, and so many. You can say ONS, GNS, net1.network, registry.acfs, and these all right. These are local, and these process will be available on that particular node. And as I told, OS is local to that particular node, and the grid infrastructure binaries are installed on all the nodes, and there's a cluster where software it is shared across all the servers. And coming to this cluster resource, you can see scan VIPs and node VIPs are all cluster resource. The scan one, if this node goes down, this scan will be shifted to any one of the surviving node, and this node VIP will be shifted to any one of the surviving node. So this all I'm going to explain in future series. So just assume that there are two kinds of resources, local resource and cluster resource. So there is a particular list, there is a OLR local repository and OCR cluster repository. So OLR is responsible for local resources and OCR is responsible for cluster resource. So this all OLR, OCR, how to manage this OLR, OCR, everything I will show you in future demos. And then this is how all together makes our rack architecture. I'll quickly connect to my servers and then I will show you. This is my host name. Host name is rack3. Host name is rack3, and then if I say ASM1 is running here. So similarly, I have other node rack4. I can say my ASM2 is running here. You can see here ASM2 is running here, and then in other node ASM1 is running here. So this ASM1 and ASM2 together makes my two node cluster. So I have this two node cluster. It is a rack cluster I have set up. This is 12201. And then what I'm going to do, I'm going to show you all these processes. CRSCTL stat resource -t. You can see these are the cluster resource, and you can say local listeners, local resource. So CRSCTL stat resource -t, it will list all your resources under that cluster. You can see this one, ASM listener, data disk group, and listeners, net1, ONS, proxy, ADVM, and then I have my scan1, scan2, scan3, this management listener, and ASM1, 2, and management DB, and this rack VIPs, node 1 VIP, node 2 VIP, and scan VIPs. So these all processes what we saw here, right? Some are local or some are cluster. This listener scan VIPs, and node VIPs. If we can see scan VIPs, node VIPs, and then scan listeners. So these are all, you can say that these are the cluster resource will managed by OCR, and rest others are OLR, that is local to your ASM or your ASM listener, net1, ONS, proxy, or local to that particular node. So that's it, guys. So this is how the rack architecture works internally. So I will deep dive into all one by one and then when we come across each service or each process, I'm going to explain in detail. So this is for today's session, that is rack uh, architecture and rack internals, how it works. So if any comments or feedback, please feel free to reach out to me on my YouTube or LinkedIn or my Instagram or all my social medias. I'm happy to help you guys. Thank you.